So welcome. This is Introduction to a Practical View of DevOps. So notice I did say introduction. If you're looking for a deep dive on DevOps, this is not the right place. Okay? So what we're going to cover today is I'm going to give you a lot of context around what DevOps is. I'm going to show you some tools, a lot of different things that organizations that are using DevOps will use in their environment. I'm also going to show you a number of demonstrations to make it real, because everything works on slides, but when we actually get into something where we have to get the tools to work together, that's where really the magic comes in. So a lot of things we're going to be talking about are really going to be around trying to understand how DevOps can be used in your environment, even if you don't have developers directly in your organization. So just a quick show of hands. I know you guys love raising your hands for these questions. How many of you have developers in your organization? Don't be shy. Oh, nice. Excellent. So I've been doing this for about 5 years. And this year is one of the first where I've seen almost everyone in the room has either developers in the organization or they have companies outside of their organization they're working with where they actually have to deal with developers in many of these issues. Okay, so it just shows you the prevalence of this. When I first started doing this talk, hardly anybody would raise their hand. They were just trying to understand what this thing was. So if we think about it, why are you here? And this isn't the big metaphysical why you're here. I'm not trying to figure out, anything that's a self-help type thing. There's other sessions maybe for that. But why are you in this session? So more than likely what we're trying to do is you're trying to figure out ways in which you can get ideas, right? Ideas for your organization, ways to be able to use things like DevOps and these types of concepts, ways to be able to compare what you're doing versus what some in the industry are doing. We always want to compare ourselves to these big organizations that have all of these developers and they're doing all these wonderful things, 100 deployments in a day. That may not be you today, right? It may not be you ever, and that's okay. But there's a lot of techniques and a lot of things they're doing that you can do within your organization to make a huge difference back to the business. And last but not least, it's really about sharpening your skills, trying to figure out what types of things that you need to be exploring. You're hearing about automation. You're hearing about programmability. All these types of things are essential for DevOps and these type of concepts. So one of the things I failed to do is to introduce myself. My name's Chris Jackson. I'm a distinguished systems engineer, and I've been with Cisco for almost 20 years. So I've seen a lot of things happen within that period of time. But the thing that I find interesting is so many of these technologies we're dealing with today. And we talk about some of these technologies we're going to be working in, specifically in a DevOps environment. Many of these technologies came about in the 70s. I mean, this stuff isn't new. It's just new ways of using it and new ways of operationalizing it. I think that's the magic part of it. So the agenda that we're going to cover today is really going to be fairly simple. We're going to talk about what this DevOps thing is. So I'm going to give you a little bit of a history. I'm not going to bore you to death. This isn't going to be one of those situations where you're going to be like, oh, I can't wait to get out of here. But I need to give you a little context of where we came from, okay? Because that helps you to understand where we're going. Then we're going to talk about why DevOps matters and why DevOps matters and the types of things that you need to deal with from that perspective. We're going to talk about going faster with DevOps. Yeah, my slides were not working the way they should have. Why within DevOps, the whole key of it is to be able to move faster. How can I get these different deployments and things that the business is asking me to do? How can I do it faster? How can I leverage these techniques to make it easier? And then last but not least, we're going to show you DevOps in action. So throughout this, I'm going to do demonstrations. It's not just going to be death by PowerPoint, because I want to make it real for you. I want you to see where these things work. And then more than anything, I want to give you some homework where you can go to be able to figure out what types of things maybe you can incorporate into your organization. And the demonstrations I'm going to be doing, I will have available to all of you, where you can download it off of my GitHub site, so you can run these applications, you can play with Kubernetes, you can get Docker running on your local machine, and you'll have a way to be able to do many of the things that I'm going to cover today in this session. Okay? So don't be shy. If you've got questions, raise your hand, and we'll address them in line. So what is this DevOps thing? Well, if we think of DevOps, you can't start a talk with DevOps and not invoke the name of Gene Kim. So Gene Kim, if you've ever read this book, The Phoenix Project, this book really kind of started the whole concept of how can we operate differently in our environments. Now, this book is not going to become a movie. anytime soon. It's not that interesting. But what you will find is the book is pretty well laid out because it shows the evolution of a fictional organization that's based on a lot of real-world examples and the things that these different companies did to be able to evolve, right? So this particular book kind of walks you through that evolution process. And I guarantee you'll find examples of where you're at in your organization, or if you've got others that you're familiar with, maybe you're a consultant, you'll see this in your customers as well, okay? Now, Gene's also been part of writing another book, the DevOps Handbook. Now, this is a great book because it shows you some very practical ways to implement many of these different techniques they talk about. So this is more of the light reading. This is more of the, okay, now how do we make this work? Right, so both of them are pretty good. So what is DevOps? From Gene's perspective, it's really a set of cultural norms. It's a way to be able to think differently about how you deploy applications, build applications, and just run them in your environment. It's a set of technical practices that allows for a very fast flow of work from the development process all the way through testing and operations. And the goal of this isn't just to be faster, but it's also to be able to preserve the reliability that we need to be successful. So if we look at DevOps and we think about it from a perspective of the components needed, as I mentioned before, it starts with culture. Culture is the most important thing for a successful organization that wants to take on DevOps to be able to address first. If the organization isn't behind it, if it's not from a management perspective all the way down, DevOps is very, very difficult because it requires people change. And we know how people love to change, right? They're always looking for ways to evolve. No, that's not true, right? But that's the one area where it becomes very difficult. People have to be bought into it. You also need a set of skills. So automation is crucial to DevOps. Many of the technologies and things that Cisco's bringing to bear from a programmability perspective is all to enable this automation piece. So DevOps simply will not function without an environment that you can program to and you can automate. You also have this concept of lean. We'll talk more about this in a little bit. But lean is a management philosophy, and it allows you to be able to look at things a little bit differently. Instead of focusing on saving money, you focus on efficiency. And how do I remove anything that's not providing value to my end result? You need to be able to measure. You've got to be able to measure the success of your application. You have to make sure that you've got a situation where you can actually understand where the application is succeeding, where it's failing, and what do we do to be able to make it better? And then last but not least, this is a shared fate environment. The developers and the operations teams, they are tied together. They sink or they swim together. And that's really fundamentally that cultural piece that we talk about. That's the part where it has to be something that is mandated from top down. And in many organizations, you'll even find that the developers and the operation teams are even in the same organization. Right? So they don't really have any separation. Now, there's no right or wrong way to do DevOps. DevOps is something that can be personalized. There's a lot of organizations that do it differently, but understand that the techniques and the things that we're talking about here, they're applicable to any type of size organization as well as any type of industry. Now, if we think about why this kind of matters, Adrian Cockcroft, if you're familiar with him, was one of the founders and the chief architects of Netflix. So Netflix is one of those companies that we look to when we think about DevOps as just a shining example of how to do it right? They did a lot of really amazing things. And the beautiful thing about what they did is they shared it for free out on the internet. So a lot of the source code for the tools they wrote, a lot of the different techniques that they use, they gave it away. They shared it, right? And that's an amazing thing because the more people that got behind it, the better it became. And you had organizations that were able to pile on, they got free development, and it was a good thing for Netflix, right? But they really did an amazing thing for the community because the things that they learned, the trials that they had, the things that didn't work, those became things that allowed the rest of the community to benefit from. So Adrian Cockcroft, made this quote, and this is really one of the most true things you'll hear when it comes to DevOps. If you have if you're doing quarterly releases and your competitor is doing daily releases, there's no way you're ever going to catch up. Look at Amazon Web Services. How many services do they have today versus what they had even a year ago? Right? It's pretty tremendous. Why? Because they keep adding services at a rate that many competitors find very difficult. Look at Netflix. They have 100 deployments a day to their service while it's running. For most of us, that would be the height of insanity. You can barely do a couple of deployments every couple of weeks, right? But they can do it in a day, over 100. That's pretty amazing. And there's lots of examples out there of organizations that are doing this successfully. So what's a challenge that we always face? Within our organizations, we have to listen to the hippo, right? The highest paid person's opinion. This is often where we end up getting our strategy and our direction, right? Now, don't go and say that the Cisco guy told you to call your boss a hippo. That won't go over well, and I'll probably get in trouble too. But just understand that this is how we typically do things. Everything's kind of top down. Well, in the case of DevOps, when we think about this new way of dealing with things, you have to be able to enable the people that understand the technology, the people that understand the applications. They have to have the decision-making power to do what's right. That's a fundamental cultural shift, as we mentioned. And the hippo, in a lot of cases, isn't going to be somebody with a crystal ball. They're not going to know exactly how things are going to lay out. They may have a good strategy. Nothing saying that there's anything wrong with this individual, but they're never going to have the view that you have, being as close to technology and the customer as they do, right? It's just a situation where you've got to kind of change the dynamic. So what does this do? The whole idea behind this is we've got to move away from this concept of listening to the hippo all the time and really focusing on this ability to be able to respond and shift and make changes. So your organization can never have enough information to be able to understand how to do better in the marketplace. You can't. You're never going to have enough information to be able to know exactly what you wanted to do. If you did, all of you would be stockbrokers, and you would all be filthy rich, right? You wouldn't even have to work anymore. But the point of the matter is, you've got to make some guesses. Well, the more you experiment, the more information you gather, right? So this culture of experimentation is crucial to DevOps. How did Netflix get as big as they did? How did Amazon get as big as they did? They did it because they continually experiment. They try new things, listen to the customer, find out what they need, what they want, and they experiment with it. The more experimentation you do, the more information you get. And ultimately, that provides you the ability to be able to make better strategies, and it's ultimately better for the business. This is what you get out of these DevOps concepts. That's why fast is so important. If I can go fast and I can experiment, I can try new things, then the ability for me to be able to make better business decisions becomes a very real concept, right? And that's something that can add tremendous value to the business. Failure is not something where you have to stop and put your head down. Failure is a stepping stone. It's a way to be able to get to the point where you can succeed. The more times that you can try things, the better off you're going to be. Again, that's a cultural shift. A lot of organizations have challenges with experimentation. They're not willing to take the risk. But I would argue the risk is in not doing it, because you won't get that information. You won't know what will work, what your customer wants. So instead of trying to get better at being able to predict the future, we need to be able to improve and adapt to the existing information and effectively use new information. That's the goal of it. And that's the concept, really, if you boil down DevOps, it's one of the key aspects and outputs of being able to try these new techniques. So why does DevOps matter? We have to take a quick step back and look at some of the history of this. So we've talked about some of the key things that you get out of DevOps. Now, where did we come from? Well, if we think about it, from the time when really programming became an official sort of skill and something that companies were looking for applications to run their business, back in the 50s is really where this kind of kicked off. Applications started to become important, business started to invest in it, and we had this approach called waterfall. Now, where did this come from? Back in the 50s, when these new programmers were looking around for a way to be able to try to figure out how to do this stuff, how to write software, what did they find? Well, they looked around at the construction industry. So if you have a situation where you're building a building, you've got to figure out what the customer needs. So you've got to get all your requirements. You've got to build a design, architect your plans for the building, you start construction, right? And then ultimately, you continue on with testing, get it validated, get it inspected, and then you've got the maintenance of the building, right? So it made perfect sense for the people at the time because it was something that was easy to be able to understand. And in fact, you had project managers that were really good at this, so they could just kind of jump over into it from a software perspective. And this is how we built software for a very, very long time. The challenges with this is it's a very sequential design approach, right? You have to do the requirements, the design. In the case of software, it's coding, testing, maintenance. The requirements and scope are completely fixed in this environment. Because just like in the construction industry, if you build the second floor and you're going to the third floor and you're starting to figure out, oh, the customer doesn't want that, they want to make changes to the first floor, you're in trouble. You can't do that. But in the case of software, the biggest problem you could run into is if you start building something that the customer doesn't want, and then you continue to build it. That's the height of stupidity, right? How many times have we seen that in the industry? So if we look at this as a perspective from a timeline perspective, we've got the analysis, we've got the design, the code, and the test phases. When we're halfway through this process, and this could be a year-long project, right? Or a 2-year project. When we're halfway through with it, we've got 100% unusable code. There's nothing of value at that point. We basically have a lot of documentation. We've talked to a lot of people, right, 6 months ago, and now we're starting to get into the coding phase. So at this point, we haven't really figured out if there's any issues that we haven't thought of yet. So what ends up happening is the coding phase where you start figuring out all these issues and things you run into. You get to the testing phase, you're out of time, you gotta ship something, and that becomes a sacrificial lamb. Anybody remember the 1.0 days, right? Whenever you get a piece of software and that 1.0 version, it was like, ugh, you knew it was gonna have all the bugs. Fast forward to where we are now, things have changed because we don't have those major releases in the same way. Now, if we look at it from the perspective of an agile development model, here, what you do is you basically flip it on its head. You still have the analysis, you still have the design, the code, and the test, but instead of it being this huge monolithic project, you slice it up into small bites. So each one of these different bites might take 2 weeks, it might take 4 weeks, but it's a very finite piece. And at each one of these, the beautiful part about it is, when I'm right here, I'm 40% complete with my project, but I've got 100% usable code. I've built things of value. That's a difference between the previous model and this one. Values identified earlier. So if I have a situation where my customer decides to make a change, which one is it gonna kill? It's gonna kill that other model, right? In this model, they can make a change. I can get the user acceptance. I can get them to check that what we're building is correct at every one of these stages, and the customer is more able to be able to influence and get exactly what they want. And we're able to be able to address change in a much more, much more effective way, as opposed to the other model, which change is very, very difficult, right? So this is fundamentally what happened. And if you think about some of the techniques that were brought to bear, this concept of lean and agile were two of the main concepts that allowed us to be able to get there. So you've got lean, which is a management process, it's a business process that really is focused on trying to find any type of waste, anything that's inefficient in the development process, get rid of it. It needs to go away. It was derived from the Toyota production system, right? The just-in-time manufacturing, all these different things that the Japanese brought to management. Well, lean is an outshoot of that. And then agile is basically an implementation of lean for the development of software. And we'll talk a little bit more about agile, but the key thing to understand about agile is these concepts of short sprints. Sprints are usually 2 weeks to 4 weeks, depends on the organization, and they're ways for us to be able to get much closer to our customer, build software, pivot with new information, and be able to make things work in a much more efficient way. So let's look at it from the perspective of an operations side. So many of you probably have dealt with this before, right? What do you care about from an operations perspective? Well, you care about everything being stable. You want to make sure that in the middle of the night, you don't get that phone call. You've got standards, you've got templates, you've got all these systems in place to be able to make sure that everything you put into place is not going to blow up the next application, or the organization can be as stable as possible. You really don't want to get bothered at 2 a.m. Your idea is success, software stable, backup and restores work, the system is operating within defined thresholds. These are very straightforward. Many of you have probably seen these kind of things before. From a developer's perspective, they've got a little bit of a different view. What do they care about? Writing software. Working code is their idea of success. They want to make sure that the APIs that they're able to communicate to, they've got good documentation, they've got libraries, they want to finish that sprint. Success to them, software works on their laptop and in test. They want to finish their sprint. That's all they care about. So what does this mean? If we take this and we look at it from a time perspective, from the developer's view, each one of these 2-week sprints is new software, right? This is a new version of code that I've got to try to implement in my environment. Well, if I've got a change window every 6 months, how difficult is that? From an operations perspective, it's like I'm being rained on software, right? Software's just hitting me in the head. I can't keep up. This is where many of you are probably sitting, where you've got some type of change window. You've got to get all these applications implemented, and it's a very, very difficult process. And it always works 100%, right? No, it doesn't. So the challenge you've got is, how do we make that easier? How do we get to be able to look more like the software development side so we can keep in pace with the software? Because as they say, if something hurts, you need to do it more often, right? It's like working out. If it really hurts after you work out, then you probably need to do it a little bit more. That's one of these examples. So today's IT service delivery is typically slow, it's manual, and it's prone for errors. Because why? We follow a waterfall approach. Most of the stuff that you're doing from an operations perspective looks just like software development back in the 50s. So how are we possibly going to be able to keep up with all these IoT devices, all these new applications, all these things the business is expecting from us? We've got to change, right? So as we look at this, we look at these concepts of DevOps, think about it from an operations perspective. That's where most of you probably live. How do we be able to take all these concepts and turn it into something meaningful back to the business? So if we take these things we've talked about, lean business principles, agile developments, operations, this DevOps model, it's really about taking an idea and turning it into money, okay? That's what that slide was supposed to be. I promise you when you get the PDFs, they're gonna work. But that's the concept, is how do we take this idea and it's something that's successful and valuable back to the business? All right, so that's the whole development aspect of it, sort of the why DevOps. Now we have to understand, how do developers move faster? So we've talked about some of the things that they do at a high level. Now let's dig down into it a little bit. So there's a concept in programming called extreme programming. And this is really just a best practices approach. This allows us to be able to take these concepts of sprints, focused on software quality, focused on listening to the customer. All of these things are really crucial to being able to write software in an agile way. It's really all about improved productivity and interacting with the customer. There's also a concept called paired programming. That's where 2 developers actually sit side by side. They're both looking at the same bit of code. Maybe they've got different domain expertise. Maybe one of them's senior, one of them's junior. But the point of the matter is, by doing that, they've got the ability to be able to catch bugs early. And that's the key thing, right? Now, nobody wants to sit like that, right? And in fact, one of the biggest challenges you'll have here is if maybe the person that you're paired with doesn't, shower a whole lot. But luckily, Cisco has technology to help you with. I can talk to somebody about telepresence. That works very well in those situations. You also have test-driven development, continuous integration, continuous delivery. We'll talk about those kind of things. So think of this as really your software development best practices. Now, we've also talked a little bit about Agile. And you can't, if you've ever heard anything about Agile, you've probably heard about Scrum. So what is Scrum? The idea of Scrum is you have this concept called a product backlog. And each one of these has something called a story. And the story is basically a feature or a function that you're going to have that is going to be added to the application. And there'll be a big list of these. And these things are going to be prioritized. There'll be certain things that will come before others, right? But each one of these different stories will be put onto a list, and then during the sprint, you'll have something called a sprint backlog. Those are the things that during that sprint we're going to work on, okay? So a sprint, in this case, is 2 weeks. So the only thing that we're going to work on is those 3 different stories that were identified. Create permit, approve permit, cancel permit. Those are the things we're going to focus on. And then during that 2-week period of time, every 24 hours, we're going to have something called a daily scrum. And the daily scrum is as simple as a stand-up meeting, less than 15 minutes, where you ask basically 3 questions. What did you do yesterday? What are you doing today? What kind of problems did you run into? That's it. The idea is to be able to get everybody on the same page. And then the goal after those 2 weeks is I've got a potentially shippable incremental software release. So what is Scrum? It's a project management tool. It's designed to be able to get us to be able to understand all these features, all these capabilities, without getting it in a situation where the developers are overwhelmed. Because what happens in the case of if you're driving on a highway, right? Everybody's there, you're in traffic. What does that highway become? It becomes a parking lot. No one can go anywhere because there's too many cars on the road. So from a perspective of a developer, if I've got too many features I'm working on at the same time, quality is going to go in the tank. I'm not going to be able to meet my requirements, and I won't be able to deliver that software on time. So this is a project management tool that's designed to be able to help with the flow of work throughout the system. Again, back to that lean concept, back to that management approach. How many of you do scrums today? Any of you do it? Okay. This is something that I highly recommend. You could apply this to your personal life. You can apply this to your children, right? Many of these concepts are absolutely great at being able to deal with any type of project management. It doesn't have to just be software. In fact, there's a book out there called Personal Scrum, right? And it really is all about trying to use these techniques in your own personal life, okay? So don't think it's just about software development. It's really a pretty good approach. Now, you also have something called Kanban. How many of you have dealt with Kanban boards before? Good. So this is very different. Again, as we start getting more and more exposure to this, developers become more important to our organizations, we're hearing these concepts. So a Kanban board is basically just a Japanese term for signal board. It's designed to be able to help understand what's going on at any particular time. And if you've ever walked into a room where they're doing Kanban and they've got a physical Kanban board, they literally will have hundreds of these Post-it notes that they have on their board, and they move them to the different stages of completion or work progress. And it's a way so that anybody can walk in there and instantly know what the status of the project is. Now, granted, this doesn't have to be physical. There's many different tools out there to do this electronically. Jira is probably the biggest one out there, right? So the Jira application will provide you a Kanban board that is electronic. But this is something that, again, helps to be able to improve productivity and manage the flow of work. All right, lots of stuff, lots of terminology. How does it work together? So if we look at it from a lean perspective, that's at the business level. That's a decision process where the business has to say, you know what, we're going to get rid of anything that doesn't add value. Underneath that, you've got Agile, which is more at the IT level, right, in the development level. You've got Scrum for project management. You've got Kanban to be able to keep everybody on task and to be able to address the software project as a whole. And then you've got the extreme programming for your software engineering best practices. So that's how it all works together. Now, granted, there's other types of things you may see in the organization, but this is an example of some of the more common things that I've seen. All right, so let's talk about making operations faster. Operations is something that is one of the most difficult pieces to be able to address. Because the cool thing about software development is it's in a vacuum. It's really easy. Well, it's easy is a tough term, but it's easy to be able to implement technologies and techniques like this because most of it's done on your laptop, right? So a lot of the things that they do, and the software developers, if you're talking to them, it works on my laptop. You operations people just need to figure it out. That's a problem. That's one of the things DevOps is trying to address. So how do we make operations faster? Well, we also have to understand a little bit about what's changed from software development perspective. What types of software are people writing? How many of you heard of a concept called microservices? I would expect almost everyone, right? So a microservice is a new way of being able to write software that allows you to be able to create very small and focused pieces of software. So the idea is it's stateless and loosely coupled. So that piece of software does one thing, and it does one thing very well. And it's fast. And oh, by the way, it's also language and technology independent. So that little service, I could rewrite, I could pull out, I could change, doesn't blow the whole application up. If we look at previous ways of developing applications, the monolithic approach, you've got dependencies, you've got drivers, you've got all these things that you've got to get to work together, and they can be extremely complex. In the case of the microservice, it's built in these capabilities of being able to switch out these different components. It's huge. In fact, most of these microservices will communicate via REST, right? It's a very, very easy way to be able to write modular software. And then by definition, you've got a very highly scalable and fault-tolerant application. Have you ever heard of the concept built to fail, where the application is built to be able to address failures? In fact, if you go to Netflix and you look at some of the ways they handle it, they actually have something called the Simian Army. And one of the applications they created was called Chaos Monkey. And Chaos Monkey will go in and randomly shut down, in production, live services to test the fault tolerance of the application itself. They even have Chaos Gorilla, which will take an entire availability zones out. You've got to really trust your software to run tools like that on it, right? But that shows you some of the different techniques you get when you leverage things like microservices. So microservices are something that we're seeing becoming more and more important as we look at ways that software is evolving. That's not to say you won't see monolithic applications. You'll still see them out there, but the move to microservices is a very logical approach. In fact, many of you and many of the organizations that I've worked with, they're looking for ways to be able to evolve or refactor an existing application into a microservices application today. And where's the first place they start? That front end, right? The web layer or the presentation layer. So a lot of these different things, again, are happening in production today. So this application evolution is driving technology adoption. It's changing the way technology looks. So everybody's familiar with the virtual machine, right? It was created as a way to be able to take these physical pieces of hardware where we were using like 20% of the value of it and being able to maximize it so that we can run more and more of these different services at the same time. Go to the container. The container was built as a way to be able to address the challenges with the virtual machine, because the virtual machine started to become a way to be able to package software. Well, what's the smallest virtual machine you're probably going to see out there? Probably about a gigabyte, with any type of application on it, at least a gigabyte. Lots of wasted space. You've got a lot of the same operating system in many cases that you're duplicating. All these types of things are a challenge. From a resource perspective, it's just not efficient for packaging software. So the container was created as a way to be able to address this. The container basically used technology from the 70s, right? Control groups, namespaces, as a way to be able to create an isolated process that you could just run it like you would an application on your host in an isolated way. Well, that's great, because then the size difference between what I have from a virtual machine is orders of magnitude smaller. I can have a container that's 200 megabytes, right, running an application. In fact, Nginx is 38 megabytes, which is a very popular web service. So I can run an Apache with Linux, all these different things in a virtual machine. Maybe I'm up to a gig, or I can run a 38 megabyte container that I can also launch in 500 milliseconds. Which do you want to do? That's why you're seeing such a push towards this. And then we've got serverless. Serverless is the worst name ever. Of course there's a server involved, right? This is also referred to as function as a service. This allows us to be able to basically take even that container and put it out of the picture. So instead of having to worry about loading a container environment, I basically just put my code into this serverless function, and it just runs the code. So AWS Lambda is an example of a serverless environment, right? So this allows us to be able to have a very simple service that I can call from my application, use it. It's designed to be used, it's not going to be kept up a long time like a virtual machine. It would basically be used, and then it would be shut down. That's the idea of that serverless function. Next time I do this, it'll probably be something else, right? That's even smaller, some other technique. But the point of the matter is the applications are changing it. So where are we at today? The container is starting to become the de facto packaging mechanism for software. Does that mean virtual machines are going away? No. In fact, many containers are being run in virtual machines. So the technologies that you're using today, it's just more in the tool chest, right? You just got more things that you can leverage. Well, anytime you add new technologies, you can run into some challenge from an operational perspective. That's what we've got to solve for. So if we look at the container and we think about what's the difference between it, the virtual machine, we're emulating hardware. The container, we're emulating the kernel. So the kernel is the point in which our applications and our libraries can communicate to the host operating system, whereas with the virtual machine, I'm simulating everything. The CPU, memory, all the different things in there. Again, from an efficient use perspective, it's a no-brainer from a container's perspective. So if I want to run multiple applications at the same time, containers are the way to go. If I want to be able to use virtual machines, if I don't want to, when you want to run multiple apps and things like that on the same machine, that's when you would use a virtual machine over a container. But again, in the case of the container, you just run those applications in other containers. Right? So it's just one of those types of scenarios. So what's the impact of containers on DevOps? They really has allowed for us to be able to better align the DevOps to DevOps. So from the perspective of understanding what's inside the container, the developers focus inside the container, the operations focus on the outside of the container. The beautiful part about this is it gives you a separation of responsibility, but provides a very seamless handoff for that software. If it works on the development side on your laptop in that container, when you move to the operational side, the reality is it's going to work in operations, in most cases, just like it did on your laptop. That's a huge productivity benefit. I don't have to load software, I don't have to do anything. You just give me the container from an operations perspective, I just deploy it. That makes a huge difference from an efficiency perspective too. We also have to look at the impact of containers on DevOps. Guaranteed consistency, as we mentioned. What's built on the laptop will work in the operational side. You've got a community of best-of-breed containers already out there. So Docker Hub is an example of being able to use some of these containers. You can pull them down. You don't have to load them yourself. And it allows you to be able to get things up and running very quickly. You've also got it from a speed perspective. You can deploy in seconds or microseconds, as opposed to the minutes it takes for a virtual machine to load up. Huge difference in efficiency. So let's look at the containerization of a simple web app. So here we have our traditional LAMP stack: Linux, Apache, MySQL, PHP. So here I am running on a virtual machine. So I've got 3 virtual machines. I'm running Linux. I've got binaries and libraries. I've got all these different things that I need for each one of them. Each one of them I got a patch. Each one of them I have to deal with all the intricacies of drivers and dependencies associated with it. On the side of the container, I have one host operating system. This could be a Windows box, or this could be a Linux server, right? The applications that I write then are tied to that particular kernel, and I've got the Apache and PHP tied together in one kernel, or excuse me, one container, because they naturally go together. And I've got MySQL loaded in another container to be able to allow me to be able to leverage that application. Scalability, significantly higher. The ability to be able to not have to worry about patching. In this situation, if I get an update to like an SSL library, for example, which are always needing updates, on a container side, I can just take that SSL piece of the software, load that in to the container, redeploy it instantly. I've got the latest version of software every time I deploy it. On the VM side, I've got to go in and patch this stuff every single time. Huge difference from an operational perspective. So this is a simple example, but hopefully it shows you that many of the applications you're using today can be containerized. They can be used in a different way today, even with the existing applications you currently have. All right, so let me show you a quick demonstration of Docker. So hopefully the demo gods will smile on me today. Well, the presentation gods are not smiling today. my AV guy's not in here either. All right, let's see if we can do this. Okay. Yeah, would you mind saying something? I'll tell you what, let's go ahead and do this. I'm going to go ahead, I will do this demonstration as soon as we can get the AV people to fix this. Maybe if I throw it around a little bit, it'll work. Guess not. All right. So from oh, there we go. It's because you walked out there. Thank you. Thank you for that. So life is good. Okay, good. All right, so let's do this. Let me make this bigger because I know no one can see that. So hopefully that's a little bit better. All right, so the first thing to understand is Docker is a command line tool set. There's a lot of things that we can do to be able to leverage these capabilities. The beautiful part about Docker is it's something that's absolutely free. So what do you pay for when you buy Docker's premium products? Well, you pay for their management tools. You pay for their front ends, their GUIs, many of those different types of things. If you want to use Docker today, you can download it from free from Docker, load it on your Windows or Mac operating system, and use it as much as you want. There's no requirements for you to pay for it, okay? Docker is extremely scriptable. By definition, it was designed to be able to, to be scripted for automation. So the first thing we want to do is look at Docker, take a quick look at the operating system. So this tells me everything's working. So I'm running a current version of Docker. I've got connectivity from the client back to the server, the Docker engine. The Docker engine is the component in the background that actually runs the containers and launches them. Now the interesting thing, and this kind of gets into how they do their magic. On my laptop here, what's happening in the background is Docker is actually loading a virtual machine that's running Linux. Okay? So it's running Ubuntu virtual machine in the background. So whenever I type a command from the Docker command, it's actually connecting back to that virtual machine on the server in the background. I don't see it, but it allows me to be able to then run Linux operating system applications on my Mac. Okay? We look at the Windows side, does the exact same thing. In fact, it will run a virtual machine, and it's a Ubuntu virtual machine on the Windows in the background using Hyper-V. So if you love Hyper-V, you're in for a treat. If you don't love Hyper-V, there's another tool that you can use called Docker Toolbox, and then you can use VirtualBox and things like that. But the bottom line is, it does the same concept on the Windows side, okay? Now there is native support for Windows containers on Windows, so that means you don't have to run a virtual machine, you can do it internally, okay? So understand that when you write an application for Windows, you can't run it on a Linux virtual machine. Makes sense, right? So in the case of Docker, for me to be able to run a Windows Docker container, a true Windows container, I have to use it on a Windows machine. So there's a little bit of a operating system requirement because again, you're virtualizing the kernel, you're not virtualizing the machine. Does that make sense? Okay. So the first thing I want to do is let's go ahead and take a quick look at Docker. So I'm going to go ahead and do a Docker run. I'm going to do it interactively, and I'm going to pull down Ubuntu, and then I'm going to launch a bash shell. So what will happen here is it'll go out and it'll look to see if I've already downloaded the image. Since I haven't, it's pulling it down from Docker Hub. So remember me telling you about Docker Hub, that repository for all these images are already created? How long did that take me to do? Seconds, right? So I now have a Ubuntu base image where I could then create my own stuff. And as you can see here, I'm now connected to that container. So if I do a PS, you'll actually see I'm on a container. I've got just a couple of services running. It's isolated from my existing operating system. Uname /r. So you can see I'm running a Linux environment. Okay. Now I'll hit Control P and Control Q, and now I'm back to my Mac. Okay. Now to be able to see the containers I have running, I can do a Docker PS, and that'll show me the current containers. So I've got a container ID, I've got an image that I pulled down, and then the commands that are running. And then you'll notice there's also some crazy name here, Nostalgic Bell, right? That's dynamically applied. I can name it if I wanted to, but in order to be able to provide a unique name, Docker provides some pretty interesting ones. In fact, I had one that said something about amazing. You know, it was something that totally inappropriate when I did this, and I was like, I'm just not even gonna make a joke about it. But the point of the matter is, if you want to force it to name something, you can. But as you can see here, I now have that container up and running, and if I want to be able to connect back to it, I just do a Docker attach, and then I can type in the first part of the ID, so 1.6, and I just hit tab, and it auto-completed, and then I'm back to my container. Okay? So that's a simple container. Now, let me show you an even easier way to be able to get something up and running. So here, let me go ahead and stop it. There we go. All right, so now let's take a look at something called Kitematic. So this is loaded when you actually download Docker from a Docker's hub or from their store. So once you load it, you have the option to be able to install something called Kitematic. And what Kitematic is it's a tool that you can use, a graphical tool, to be able to create containers. So here, I can search for all kinds of different containers. If I want to load Minecraft, I can load Minecraft. You know, if this was Fortnite, you'd be the coolest person in the world, evidently. But Minecraft, that used to be very cool. And when I first started messing around with Docker, I was able to host a lot of Minecraft environments for my kids at home. And I was like king of the nerds at that point, right? But the point of the matter is, all of these containers are already built. So many of the things that we're talking about here, you can just go and download. So that first one up there, this Hello World Nginx, if I want to be able to download this, I can just click it. It'll connect up to Docker Hub, and it'll start downloading that container. And it's pretty quick, as you can see. Now, how difficult is it to configure? I go to Settings. I need to be able to share my host name. Now, you'll notice here that we get a default host name, or excuse me, a port that is in a high-ordered port, right? It does this to be able to allow for multiple containers to be able to use the same port. Because I only have one port 80 on my NIC card, right? So in order to be able to support that, Docker will go in and be able to and actually create a random port number. Now, we'll talk about how you address those kind of things later, but just understand that's what's the default. So here, if I want to be able to make, you know, my local host to 80, save that, and then since this is an Nginx file, I need to be able to share some HTML, right? So if I want to be able to share some local HTML, I can go in and change this and be able to share this folder on my local machine, open it, and then now I have a fully functioning container running Nginx, which is a web server. So let's see what we have here. Oh, think we should play that? Nobody wants to be rickrolled today? All right. So yeah, this is just a simple HTML file, but it shows you how quickly you can set up a web server using Nginx and Docker Hub. That took me, what, seconds? You know, in fact, I was asked to actually set up a web server. You know, they were having some problems getting something hosted, and I'll pop one of these up for an event we were doing. My VP thought I was like some type of wizard. You know, so this, again, just one of those types of things where you can come out like a hero just playing with Docker. Okay? So yeah, we won't listen to Mr. Rick Ashley playing his good stuff there. All right, so that's Docker. Again, download Docker. It's something for free. Highly recommend you play around with it. Okay. Okay. All right, so showed you an example of Docker, showed you how you can use it, the value of those containers, how you can use them in your environment. Well, it's great when I've got one, right? So here's what I did. I basically went in, I launched a container, I used port 80, mapped it to my local network card. Well, that's great, but what do I do when I've got multiple containers? Using port 80. In this situation, the operating system in Docker will be able to provide you random port numbers That's a challenge. How do you find the right port number? And what happens if you got multiple virtual machines running the same container all through your data center, all using port 80, and I need to have some way of being able to find the appropriate container, maybe load balance across them. How do you deal with that? Well, ultimately it comes down to a number of challenges you deal with in the container environment. You have to be able to address the dynamic aspect of the container. They will come up, they will come down. It's called ephemeral, right? It's ephemeral aspect of them. You've got the ports you've got to deal with, the efficiency of where you place the containers. How do you handle that across your data center? You got multiple pods in your data center. How do you address that? How do you make sure that the ones that you're using are tied to the networks that they need to? How do you deal with persistent storage? All these things are very difficult to do. You also need to be able to address, again, that placement and the efficiency of it. And there's a number of different solutions out there. So Mesos is something that's evolved over the years. It started out as a tool that's primarily used for big data. They supported Kubernetes earlier on. You had the ability to be able to support containers as well. You had Docker Swarm, which is Docker's paid version of it. Well, let me rephrase that. Docker data centers are paid version. Swarm is a container orchestration engine that you can use, and it's free as well. You can download it. But by far, the big dog out there is Kubernetes. How many of you are familiar with Kubernetes? Okay, so Kubernetes is something that, when it first came out, people were absolutely amazed at how far it was. So Google provided this as something back to the community back in 2014. They offered it from an existing project that they had called Project Borg. Now, the way that they actually deal with containers today is different. They have a different system they use as part of their special sauce and how they can address it. But the technology and some of the core technology is available in Kubernetes. And that's a very cool thing. They gave that to the industry. Now, the interesting thing about Google is they launch billions of containers. Billions, right? It's amazing the amount of things that they deal with. So the good thing about Kubernetes is it's very, very scalable. And it had many of the things from those challenges we just identified addressed. So why are we so bullish on Kubernetes at Cisco? Because this is where the industry is absolutely going. Everybody's supporting it. VMware supports it. Docker supports it. Everyone. So what is it built on? It's built on the Go language, which is Google's language. It's portable, extensible. It's got plug-in capabilities. You've got the ability to be able to have a very extensible and modular environment. It's self-healing, auto-scaling, auto-replication, and it's free. It was given to the Cloud Native Compute Foundation back in 2015. So the evolution that you see in Kubernetes is tremendous. Every 3 months, they have a major release. Every 3 months. Keeping up with it is very, very difficult. That's one of the challenges when you have so much rapid development happening, okay? So don't think Kubernetes is easy. It's not difficult to get it up and running, but operationalizing it, that can be a challenge. Oh, one other thing we've got to talk about, K8s. Anybody know where that comes from? If you count the letters between K and the S in Kubernetes, there's 8 of them. Nerds, right? They do stuff like that. So if you ever see K8s, it's just another term for Kubernetes. All right, so what does Kubernetes look like? So there's a number of different components you have. You've got the master and you've got the nodes. So the master has the scheduler, it's got a controller manager, it's got etcd, which is a key value store, and it's got the APIs that you use to be able to communicate out to the nodes. There's a number of ways you can interact with it. You've got APIs that you can use, you've got CLI, and you've got a user interface, okay? So it came out of the box pretty much ready to go. Now, when we look at the node itself, you've got the pod, which is a set of containers. So whenever you see pods, you can think of containers, and it could be more than one container, right? But the idea is you've got, like dolphins, you've got a pod where you've got multiple ones together. That's the concept behind it, okay? You've got Docker as your runtime for your containers. This is probably loaded on a virtual machine somewhere. And then you've got the kubelet, which is a way that you can communicate back to the master. And you've got kube proxy, which is used to be able to provide services and address that whole, how do I get to my container and find it, okay? So all these things are built into Kubernetes, all from the ground up. Now let's understand Kubernetes a little bit deeper. So this is a way to be able to approach how it works in a very simplified way. So the first thing we have to understand is Kubernetes, again, is built in a cluster. So if you're going to deploy this in real life, you typically want to have 3 masters for redundancy, and then you want to have a number of your different nodes, which in this case I've got 3. Okay? Now, whenever we play with some of the tools like Minikube and some of the things I'm going to talk about in a little bit, that's generally going to be 1 master because it's in a testing environment. But in real life, you want to have at least 3. Okay? So here I've got my, my nodes and my master. I've got 2 different ways to be able to communicate to it. I've got kube control, and there's all kinds of arguments about how do you pronounce that, by the way. So if you ever come into somebody and you say, well, that's kube control, they may say, no, that's kube cuddle, or about 10 other different variations. At the end of the day, tell them, look, let's talk about what it does, and let's not talk about how you pronounce it, because there's a million ways that people think they can pronounce it. I want to control Kubernetes, so I call it kube control. All right, so you have your interface on your website, and you've got kube control. So kube control is the tool that you're going to use to be able to interact with the Kubernetes cluster. You have your scheduling that occurs between the nodes. So in this situation, I want to be able to create a container out here on a particular node. So this is going to be pod 4. So I create a file called, it's a YAML file, which allows me to be able to describe what that service is. So here, I've got this big web stuff, running test web container, WebX, web container is the name, and I'm using Nginx and the container port 80. So I basically describe what the container is, what it's running, and I give it a name so I can find it again. Once I deploy that, I just use kube control to be able to push that out and deploy it into my environment. Now, what if I want to do multiple containers? So in this situation, I've got multiple containers I want to be able to deploy. I've got it in 2 pods because I want to be able to address it from a replication perspective. So Kubernetes has a built-in replication capability. So in order to be able to have redundancy and failover, I can define in this YAML file how I want to be able to support that. So at any one time, I need to have at least 2 versions of this container running. Don't care where it's at. You decide where the best place to do it, right? Talking to Kubernetes. You decide where the best place to do it, but you've got to have 2 of them up at any time, okay? This file, again, same type of concept, describing it. The replicas equals 2. That allows me to be able to control it, okay? What happens if one of the containers is deleted or stops? The replica system automatically spawns a new one. It's all built into it. You don't have to do anything else. So how do I address the service aspect of it? How do I reach these containers? I need to create a service profile. And this service is actually going to be used to be able to communicate to that Kubernetes environment. So here I'm going to be able to connect up to this test web. I'm going to use a cluster IP address. In this case, it's going to give me 192.168.20.10. And then I'm going to expose port 80. And then the system will automatically load and balance between any number of containers that I already have. It really could, it's that easy. I know that sounds crazy, but that's one of the benefits of Kubernetes. It's all built into it from the ground up. Okay? Now, that is going to give you kind of that high-level overview. Now, if you ever did any searching on the documentation for Kubernetes, you'll know that a lot of things I just described, there's a lot more involved in some of the different pieces. But to do what I just described here, it's literally 3 YAML files and a couple of commands. Okay? And I'll show you some examples here in a second. So microservices, right? We've talked about this. You can see the value of containers. You can see how containers are brought into this world. But in order to be able to have all these different services communicating back and forth to each other, it's a ton of east-west traffic. There's a lot of information that's occurring between these. I've got database services. I've got parts of my application that need to be able to communicate to each other. How do I secure this? How do I segment it? Right? How do I ensure the quality and the value of certain parts of these services? Some of these services are worth more than others. The services that are handling my billing and accounting and credit card transactions, they're very valuable. They've got a much higher attack surface, so I need to be able to protect that in a different way. I need to understand how these different applications are functioning, right? How are these services working? Are they efficient? Are there challenges with the code? How do I figure that piece out? And ultimately, it comes down to understanding that these microservices and these different components, while it sounds great, this automatic scaling and things like that, when we look at what this looks like in production in a very large environment, you've got a couple of different examples here. That's a Netflix in the middle. That's a ride-sharing program over there on the left. And you've got Twitter. So 450 microservices, 500 plus on the side of Twitter. It's like operating the Death Star. It's huge, right? Why do they say that? Because that looks kind of like the Death Star. Again, nerds. But these are the kind of things that you've got to try to figure out. So I got you excited about containers, and I said, oh, by the way, it's not easy, right? You're going to have to hire a couple people with some different skills, right? So how do you address that? So being able to operate these different microservices and these apps, again, it's not easy, but we have tools to be able to help you with that. So why did we acquire App Dynamics? To be able to understand how the applications work. So I can get visibility into how all these different apps are functioning, how they're communicating, where some challenges might be. How do I address issues with the application itself? I get unprecedented visibility. So App Dynamics is designed to be able to be a friend for the developers themselves. So developers will take components of App Dynamics, they'll load it into their application. It'll give them the ability to be able to get instrumentation where they can get information from the application, and then ultimately allows them to be able to do a better job at being able to operationalize their environment. Now, how do I handle segmentation with containers? What's a tool that we have? Tetration. Tetration will understand your applications. So think of App Dynamics as being able to understand inside the application. Tetration understands how the application communicates, right? That's how the two of them work together, okay? All right. So we've talked a little bit about some of those challenges. So one of the things we have to understand is there's other concepts here to be able to make operations faster called infrastructure as code. Any of you have heard of this concept? Hank Preston does a bunch of wonderful talks on his whole net DevOps conversation. It's really about providing a new way of addressing how you instrument and how you deploy your infrastructure environment. So infrastructure as code, otherwise referred to as configuration management. It's being able to write code that defines our environment as opposed to going in and individually configuring it, okay? So this isn't anything new. You've heard a lot of these different concepts. Now there's tools out there, Puppet, Chef, Ansible, NetConf, Yang, whatever you want to use, it doesn't matter. But the point of the matter is use software development principles to be able to operationalize your environment. It allows you to be able to move faster. It's a key component of DevOps and a key component of being able to leverage some of these techniques in your existing environment. And that's not to say that you're maybe ready to flip the switch and go completely automated today, but start in parts of your network. Find ways where you can start to leverage some of these technologies because you'll find that they make your life so much easier. So we talked about immutable infrastructure, we need to talk about immutable infrastructure. This is a concept where it provides you the capability of having an environment that is unchanging over time or unable to be changed. So what does immutable mean? It's basically just a scary college word that says that I'm not going to change it, okay? If I need to be able to update it, I'm going to blow it away and I'm going to create a new one. So instead of this patching game where we always are going in and adding all this new software and constantly overriding these virtual machines, right? I'm going to basically go in, once I instantiate something, it doesn't change. When I need to replace it, I build a new instance. So what does that look like? So if I need to be able to update an application, I have to patch it on a mutable server, on an immutable server, I launch a new one, destroy the old one. If I need to update the operating system, right, you know this game. Here I just basically blow it away. Now what's the benefit of this? There's a concept in software called software entropy, right? Software entropy means that the more stuff I load on there and the more patching I do, the slower it gets. Problems occur. What happens if a patch doesn't completely take? Has that ever happened? Of course it has. In this environment, I don't have to worry about that. It completely eliminates the need to do patching because every time I instantiate this new version, I get the latest version of software. All the bug fixes, everything is loaded dynamically. So what does this mean from an operational perspective, your traditional VM versus container delivery model? Your traditional VM, 2 to 5 minutes. You've got software entropy you're dealing with. To be able to address this, to be able to come back from recovery, it can take up to 10 minutes to restore this environment. Maybe even longer, right? Depending upon how quickly you can load those VMs and how big they are. On the container side, a container can reinstantiate in 500 milliseconds. It's just like launching a new application. Once it's loaded in memory, you just pop up another one. Each time you get a new instantiation, it has the latest packages, immutable delivery model in this situation, 2 to 3 seconds for restoration. So how does an environment like Facebook or Netflix, how do they handle failures? How can they do these number of releases so many times in a day? Because they have an environment like this, where they can go in, they can make these changes, they can update the code, test it, and there's many different techniques where they can use it. Canary environments, A, B, red, blue. There's many different ways in which you can do this in practice. There's patterns that you can follow. But the point of the matter is, this is the technology that allows them to do it. This is how DevOps works on the operational side. You also have things from Cisco, like Cisco's container platform. This is a turnkey solution. It's 100% native Kubernetes, direct updates, best practices, everything. Hybrid cloud optimized, integrated, flexible deployment models, everything from a VM to bare metal to Hyperflex to ACI, doesn't matter, right? So it uses something called Contiv to be able to address networking, where you can directly integrate your ACI environment into your container world. So back to how do you do all that segmentation? I can do that now with something like CCP. Okay? All right, so let's show a quick demonstration of Kubernetes. So hopefully this will, yeah, good. All right, I was about to get sad. All right, so let's make this a little bit bigger. All right, so there's a number of commands here that we use. So you saw before when we were using Docker. So Docker is a command line tool that allows me to be able to communicate to the Docker engine. Kube Control is a very similar tool. So both of these are client-server tools, and that's the beauty of these. So the Docker command that I was using before basically just hits the API that's running on my Docker daemon. Okay? Kube Control just hits the API that's running on my Kubernetes cluster. So in the case of what I'm running here, I'm actually running something called Minikube. So I have a local Kubernetes cluster sitting right here on my laptop. Okay? So in order to be able to make sure everything's working, I type kube control version, and it'll spit back that yes, the client is working, and yes, I can communicate to the server. That's a little bit harder to read because kube control is really designed for automation. Okay? But you can see very quickly that everything's working as it should. I can communicate to it. So one of the first things I want to do is I want to deploy an application. So you saw how we did it with Docker. So in order to be able to do it with Kubernetes, I do kube control, deploy, all right, hold on 1 second. Oh, hold on. Let me get my cheat sheet out. All right, so the first thing, well, that's the wrong one. Hold on 1 second. There we go. All right. So the first thing we want to do is we want to deploy an Nginx server into Kubernetes. So here we're going to go ahead and do kube control run Nginx, image Nginx, and then we're going to be able to put it on port 80. Okay? So this is going to go ahead and deploy Nginx to my Kubernetes cluster. Okay? Now I need to be able to access it, right? So I need to be able to create a service. And that service so there's deploying the container. Here's deploying the service. So here we're going to expose deployment Nginx type node port, port 80, okay? This, once I hit enter, will then expose that service to Kubernetes. So now I can type in minikube, which I'm using minikube as my underlying Kubernetes, so I've got a built-in tool set that I can use here, and type in service, Nginx, and what this is going to do is it's going to automatically launch a web browser so I can then get access to that service I just created. So here, it launches my Nginx environment. Really fast, right? The beautiful part about this, again, is it's extremely easy to be able to do. So here on my Kubernetes side, I've got my desktop, or excuse me, my web application. So here I can see a quick overview of all the different services I'm running on this particular laptop. So I've got my CPU usage, my memory usage. Notice here, this is that Nginx container that I just created. That's kind of hard to see, but that's that top one is the Nginx container. I've got the replica sets that were created, and then I've got the service node. So this actually ties it back via port 80 to that container. All of this was done in the background. So did I need to know where the container was? Did I need to know what IP address it currently had? Did I need to know what port it was giving? No, it was all done for me. That's why Kubernetes is so hot, because these types of things make it extremely easy, okay? This particular interface is really more designed. It's not really how most organizations interact with Kubernetes. They'll primarily use it for management or monitoring more than anything else. Most of the tools that they're going to use will be those command lines to be able to control it, or they'll automate it, right? Or they'll use something else on top of it that will go in and basically, you know, what you'll see in the future is Kubernetes will just kind of be the engine under the hood, and the other tools will kind of control it. That's often what you're going to see in these environments. But this is an example, again, of using a tool called Minikube, which is a Kubernetes cluster that you can download to your laptop to be able to get your own Kubernetes cluster that you can play around with and experiment with, okay? And this is the exact same software that they run on full-blown, in-production Kubernetes environments, okay? Cool. All right, so how do we go fast safely? So I've given you some examples of how operations can use some of these different tools. I've shown you Docker, I've shown you Kubernetes. Now, what do we have to do about security? Security is obviously an important thing that we have to deal with here, right? So how can I handle that in these environments? Well, one of the things I've got to focus on is the fact that, you know what, we talked a lot about development or DevOps and things like that, but we didn't really talk about the security piece. And a lot of people will say, well, configuration management tools will help me with security because I can just create templates, right? Security templates and things like that. You know, these aren't going to really replace security expertise, but by standardizing some of these different things and making sure that your security team is involved in the creation of it, you can have a very, very good templatized environments that will address most issues. It's not going to replace your security folks. I know some of you would probably like to do that. Unless you're on the security team, then you'd like to replace the operations people. But the point of the matter is, once you create those templates, it makes things a lot easier. Because how do we see a lot of these hacks occurring? People get in because somebody did a manual configuration, they forgot to check something, and that system became a jump point to be able to get to other systems in the environment, okay? By being able to standardize and use configuration management techniques like what we've talked about, using some of these capabilities as automation, we can standardize on that. We also need to be able to understand that we have to have it inserted into the DevOps process. It can't be something where it's a bolt-on at the end, right? There's no tool you're going to buy that's going to protect your DevOps environment. It really has to be something that you leverage together. So DevSecOps is something that's a big thing today. There's a lot of organizations out there that are trying to understand how to be able to implement security within the DevOps environment. These are a couple of examples out there. So rugged software is an approach to use to be able to integrate security into software development. So that's more for the software developers to be able to look at. It's how to be able to make sure that they are building their software to be as rugged as possible so that they don't have as many situations where they're using code that maybe is potentially exploitable. right? All the different buffer overflows, all the different things you're going to see from a security perspective. How do we get that out of it from the beginning? And then you've got other tools out there that go in and will automatically test it. So Gauntlet's a free one, and it has by far one of the coolest taglines. Be mean to your code and like it. Who doesn't want to be mean to their code? I would like it. All right, the whole idea is you have these different tools that you can insert into the process. And then OWASP is another organization that has created something called the AppSec Pipeline Project, where they've gone in and they've looked at all the different tools and they're mapping it towards different parts of the development process. So there's a lot of things out there that you can do to be able to ensure that security gets implemented into the DevOps process. And these are just some examples. So what does it look like from a build process? So this is a continuous deployment environment. I've got my development, my code commit, my source. I've got some type of build trigger where I automatically build my software. And then I need to be able to deploy it to a test environment. In that test environment, I'll then have some report and notify to tell my developers whether or not this stuff works. And then I'll publish it to a release repository. And then ultimately, I can then send it to production. Well, that sounds great, but where's the security fit in? Security has to be able to integrate into this process really at a couple different levels. First thing is you need to have secure code analysis so that you can actually test it as it's being built. And a lot of the editors out there have analysis techniques where you can load in plugins that will go in and look for very common issues that you'll find in the software development. Like don't use printf if you're writing in C. Right? Those types of things were exploited tremendously throughout history. A lot of different issues out there. So it'll catch a lot of the code violations, a lot of the challenges early on. So having that at the front end where the developer can't even commit that code unless it has gone through a test is a great first step. And there's a lot of different tools that you can use at this stage. And then, as we mentioned, that whole testing aspect of it. Once I do the software build, I can automate all this testing functionality. Well, ensure that you have your security testing in there. So you're going to see an example of using a server called Jenkins, which is a automatic build server, right, a continuous integration server, and it has a tie-in that will directly link to Gauntlet to be able to do some testing on the actual software itself. So if I need to automate that process, it's all built in. Many of these different tools already have those linkages. You don't have to create your own stuff, okay? So this is a very important aspect of it. And then ultimately, that needs to be part of the whole build and test process. So why are we spending so much time on this? Because we've got to think differently about security. We can't let it be a bolt-on. And for gosh sakes, please don't put passwords into GitHub. I can't tell you how many times I've seen people put passwords in there. In fact, you've got people that are constantly trolling GitHub looking for very common readable passwords. So the minute your password gets in there, if you forget and you do a git commit and your password is in it, go and change all of your passwords immediately because you messed up and they will probably come and get you. Okay? So please don't check passwords into GitHub. Also, TLS all of the things. Make sure everything has the ability to be able to use encryption, encrypt between microservices. TLS, or Let's Encrypt, is a free service that you can use, be able to get valid certificates that you can use in your environment. Doesn't cost anything. This used to be a real pain in the butt, but this service was something to be able to help the community so that we can use TLS and be able to encrypt between these different microservices. Again, the more you encrypt, the less likelihood that it can be circumvented. All right, so now let's talk about DevOps in action. So whenever we talk about the tool chain and we talk about tools, this is one of those things where there are more tools than there are grains of sand at the beach here in Barcelona. You've got new tools that are being created every single day. This is something called the DevOps periodic table, and it was created by an organization called Zebia Labs. And you can go out to this website, and this is an interactive map. You can click on each one of these. It'll give you details on it. And in fact, you even have an option to be able to create your own pipeline based on some of these tools. So you can go in and kind of pick the different things that you're familiar with, and then create a pipeline, and it'll show you some examples of how that would work together. And then, of course, they like to try to sell some of their products in there, too. Imagine that. Wasn't done for free. But it's a really good resource when you hear about a new tool or a developer comes to you and says, hey, I want to use this. You can see what the capabilities are and what's needed to be able to get it working. So it's a really good resource. I'm not going to go through every single tool today. I don't have enough time, okay? Nor would you probably sit through that. I'd probably lose all of you. But I wanted to give this to you because, again, I think it's a great resource. So how do we be able to take these different tools and make them work together? First, we have to understand that developers are like Goldilocks, right? Your app teams want a specific thing. Your infrastructure as a service teams, maybe they're just completely bought into the whole AWS thing, right? You've got your platform as a service teams. They've got their own way of doing business. And you've got your container as a service groups as well. All these different teams have their own tools. And these tools can often be something where it becomes more of a religious battle than anything else, right? Bottom line is, most of these tools work together, okay? They all have APIs. They can all integrate. Some are better than others. Some of them have capabilities unique to themselves. So it's about understanding what makes the most sense there. But, you know, from an operations perspective, you know, the challenge here is they need to feel the pain if you feel the pain. So back to that cultural environment. You can't have developers come in and tell you, we will use this if it doesn't make sense in your environment. So you've got to be able to have some of the tools to be able to argue your points, specifically in understanding what some of those capabilities are. So that's why I showed you that DevOps periodic table, because you'll often get tools coming down at you where you're supposed to implement them into the environment, and you're going to find that it's going to be very challenging. Okay? So just make sure that you can have those conversations, and don't get to the situation where you're going to be fighting with somebody's pet tool. Languages are another aspect of it. When we think about who likes languages and who likes these different things, again, that can be another religious battle within the developers. The beautiful thing about microservices is I don't care what language you write in, what frameworks, what tool sets, it doesn't matter. So using Python or using Go, it really doesn't matter. From an operations perspective, why is Python so important today? It's because the community is built around it. It's because the fact that you can go to GitHub and get access to already ready-made scripts that you can use and modify in your environment today. So if you're not learning Python, or you're not at least conversant enough to be able to modify a Python script, you should definitely look at that from a skill perspective that you want to gain. Okay? There are too many wonderful capabilities that you can use by leveraging Python, and to be able to use it to be able to integrate into many of these different aspects, and to make it easier to operationalize your Cisco environment. You also have, from a developer's perspective, what's on their laptop. You'll often want to be running Docker. I personally love VirtualBox. It's a great tool. You know, there's others out there you can use. You can use VMware. The challenge with VMware is sometimes you got to pay for their privilege of using their connector. So there's a licensing fee that they sometimes use. If you want to use things like Vagrant and you want to use VMware on the back end, they want to charge for that. So there's a lot of things like that you'll run into. You definitely want to be running Minikube or some Kubernetes version. In fact, the latest version of Docker even has the ability to be able to load a Docker cluster directly from the Docker toolbox, right? Or excuse me, the Docker desktop on your environment. So you can run Kubernetes, a native version of it that Docker supports, or you can run Minikube, which is also supported within the Docker environment. Okay? So however you do it, play around with Kubernetes, get familiar with it. It's going to absolutely be essential as we start looking at applications in the future. You also need to have a place to store code. So we talked a bit about GitHub. If you're not actively perusing GitHub or you're not using it, I highly recommend you go out there today and create an account. When we talk about infrastructure as code, we talk about writing software that controls our environment, we want to make sure we use software development practices, leveraging things like GitHub to be able to share our code, our configs, even in our internal environment. So GitHub is sort of like the social media platform, right? Git is an internal repository. So you may have internal Git repositories in your organization. They're two different things. You can use the free GitHub and create private environments where you can only share it within your team, or you can buy the enterprise version of Git and actually have it in your local environment. I guarantee you, your software developers probably already have something for this, if not already have a version of Git that they're using. Editors, lots of different choices out there. Everything from, Vim to Atom to Visual Studio Code. My favorite's Atom. It's a fantastic word processor, code writing application. Visual Studio Code's great as well. Both of them are completely free. And the best part about it is they have plugins that you can use. And one of the things that you'll often find is when you copy and paste things off the web, things don't work, right? Because there's a lot of hidden characters that get copied into your code. Well, things like Python are very sensitive to that kind of stuff, right? So these different editors have something called a linter. You ever got a lint on your shirt and you need to take a lint brush to get it off? Well, linter is just a piece of software that goes in and looks for that kind of junk, right? Is there an end of line? Is there a carriage return as opposed to a tab? All those things matter, especially in these YAML files and some of these different things that we're going to be dealing with Docker and stuff like that. You want to make sure that it's clean code. And just copy and pasting it off the web won't do it, okay? And the last thing you want to do is copy and paste out of a PDF. That's a nightmare without having a linter, okay? All right. Then you've got the collaboration side of it. We need to be able to use some tools so that everybody can get on the same page. So we talked about Jira from a Kanban board perspective. You can also leverage WebEx Teams, Slack. There's tons of different tools out there. Bottom line is figure out what the developers are using, figure out what makes the most sense, and use that. The worst thing you can do is introduce 2 of these things or 5 of these things. Then nobody will use it, right? It's kind of one of those scenarios. So I'd like for you to use WebEx Teams where it makes sense, but if you like Slack, more power to you. Bottom line is you want a tool that you can integrate so that you can create connections back to things like your Jenkins server or your continuous integration server so you can tell when builds are done and then you can see what's going on in the organization. Again, that's the idea of using these types of tools. You also have the concept of using these tools in a very different way from an operations perspective. Anybody heard of the term chat ops? So chat ops uses these types of tools to be able to operationalize their environment. So Meraki has a simple IT demonstration that you can go see in the hub where you can see what a chat ops environment would look like. You can type in natural language commands. You can look for user IDs in the chat program, and it goes back and connects to those systems and then spits it right back and then gives you a link to go directly to their devices. Saves you tons of time. Not difficult to implement. It's all available on GitHub. You can download it and deploy it in your organization. So there's a lot of examples like that where chat ops is becoming extremely popular from an operations perspective. And then from a development platform perspective, there's a bunch of different ways in which you can skin this. The bottom line is you need to make sure it's programmable, there's a tool ecosystem tied to it, and it's available to everyone. There's going to be certain things, depending upon what country you're in, certain services are not going to be available to you, or maybe they're not preferred based on regulatory requirements. Just make sure that it's a tool set that everybody can use and it's available. Docker Data Center we've talked about before. UCS integration with these different platforms. We've got CVDs, so when you go to deploy them, it's not like you're the first person ever to do it. You've got some tested, validated designs you can use to get these deployed. Platform as a service is another example. So many different tools we've talked about, you basically have to cobble them together. You get a box of parts, and it's like building Lego, right? You're snapping different components together, and you're hoping it's going to work together. What happens when you get a platform as a service? It's all done for you, right? So all the different components we've talked about, the build process, all that's built into these platforms as a service. So these are 2 that Cisco partners with. There's many out there. We work with all of them, okay? All right, so let's talk about operations faster. So that's the development side. So there's continuous integration, delivery, and deployment. This is an important concept because this talks about really what we're trying to drive towards. So continuous integration uses the approach of leveraging a server like a continuous integration server, which is basically a server that you can commit your software to, and it does an automated build process. So this is the very first step of this automated DevOps type world. The next thing would be continuous delivery, where the build of the software is automatically put in a repository that operations can then use. So the first thing is that continuous integration. It can be done just within the development team. When you start getting into continuous delivery, that's where the development team actually packages up the software, puts it into a repository, then operations can deploy it, okay? And the last one is the continuous deployment. That's where the entire system is automated. So from the perspective of the software being built, it goes to the repository, and then the system will automatically implement it. I'm going to show you an example of that here in a minute, okay? Of being able to leverage that as a full pipeline where I can make a change as a developer, and it automatically gets instantiated into my production environment, Again, this is code that you'll be able to download. I'll share it within the WebEx Teams so you guys can get access to it and try it on your own. So there's a number of different platforms here. This is an example of Jenkins over here. It's considered a classic mode platform. The big difference between the two really just comes down to how they handle their configuration files. The configuration on Jenkins is centralized. Everything's kind of retained in the Jenkins server itself. And then what we're seeing with these new types of tools like Travis and TeamCity and Drone is they basically have configuration is pushed into the repository, okay? Pushed into GitHub, for example. Now, the problem with this is, again, from a passwords perspective, this is a very easy way to be able to share your passwords. So just be very careful. There's a secrets that you can use with it that'll hash it and protect it, but if you don't do that, you will absolutely be sharing those. So again, be very careful with GitHub. It's wonderful, but it can be a nightmare if you share a password. Monitoring, logging, alerting, many different tools out here for this, okay? Some of the big ones you see is Prometheus. That's one that was given to us by Google as well. You've got the Elk Stack, which is Elasticstack, Logstash, Kibana. You've got Splunk. Many different tools out here. I'm not going to go through all these, but from an operations perspective, you need something that's going to parse these logs and give you visibility into the environment. So this is an example of some of the different components that we've talked about. The thing to understand is each one of these has a layer. And as you're building this pipeline, you've got to make sure that these pieces are going to work together seamlessly. So these are some examples of different tools that I'm personally familiar with that I know work well together. But again, your options, there's many different options out there, okay? This is just an example where you can start from, but you've got others that you can explore as well. Now, it's time to actually see this thing work. So this is an example of what this looks like from a diagram perspective. So I'm going to walk you through this real quick, just because it's an easy way to understand kind of what's happening in the back end. So when you have a situation where your developer needs to make a change to your software, the first thing they do is they log into GitHub. So from here, they're going to pull down the latest version of code. They're going to pull it down from the master branch that's currently on GitHub. They're going to do a git pull. From there, they have the latest version of software, the one that's shared by everyone in the organization. They can go in, they can make incremental changes to it. They can test in their local environment. They can be able to make sure that everything's working as it should. And then they will do a git commit and push that back up to GitHub. From there, once the developer does that commit, the continuous integration server, in this case Jenkins, has a hook already into GitHub. It's looking for any type of change. When there's a new commit, it'll see that, and it'll kick out an automatic build. From there, when it sees that change, it'll kick off these different tests. It'll do those unit tests. It'll do security tests. It'll build the environment so that you can replicate as close to a production environment as possible. And then it'll go in and review the results of that. All that information is then sent back to Jenkins. If there's a failure, that information is then sent back to the developer via like WebEx Teams or Slack. And in this situation, the developer can see what their issue is. They can click on it. They can see where it failed. Make those changes and restart the process. If everything works, the software is then built. After it passes its test, it's then deployed to an artifact repository. Artifact repository in software development is basically just, that's where the code goes when it's built. It's just a place to be able to store finished code, okay? From there, your artifact repository can then be picked up in a continuous delivery model and then deployed automatically to Kubernetes in production. So if the demo gods are with me, this is what we'll see today, okay? All right. I feel like I should shake a chicken at this. Okay. So here we're running Kubernetes, and luckily everything is still green. Let me refresh. Make sure it's still green. Ah, good. That's a good sign. You'll notice here I have a number of different applications. So I've got a number of components that are loaded in containers. These different components really represent an application that is the one that you can download that will show you how this works in your own environment. So this application was provided by a company called Kinzan Labs, And they, provided a free example of how to do an auto-scaling application. It's just perfect for these types of environments where you want to be able to test it, you want to experiment with it. It's just a great application without you having to go out and build your own. So this application is really pretty straightforward. It's a little puzzle. So let me see if I can find it. So here is the puzzle application. So this application uses a couple of different pieces. It's got a number of different, it's got a front-end application, it's got the puzzle, which is the actual logic of the application. That's loaded in a separate container. It uses a shared database, so MongoDB. MongoDB is very, very popular today. A lot of customers are using it. There's many different databases like this. But the point is, it's a NoSQL environment. So it's designed to be able to share across these different, these different applications. We use etcd to be able to handle the auto replication and scaling, which etcd, if you remember, is a core component of Kubernetes. So that handles all the pieces on the back end. Now you'll notice here that this application has a number of cool features. So notice here I can scale. So I can actually slide this button. So we'll go ahead and go to 5. I can click scale, and it popped up those containers. So how long did that take me? It was like milliseconds, right? That's the power of having these containers. If I need to scale it based on load, I can scale it up in an instant, right, in milliseconds here. So this shows you that auto-scaling function. And if we go back to Kubernetes, you'll actually see where those different puzzle components, right, were built up. So here's the different containers that were constructed based on that auto-scaling. Okay? If I want to be able to remove them, I can scale back down. Okay? So how would I automate this? Basically, I look at the front end, I see how many people are connecting my application, and I just dynamically scale it based on load. Right? How does Netflix do it when everybody wants to watch the same movie at the same time? Right? They don't know who's going to want to watch what. They've got a pretty good idea because they continually monitor the environment, but they've got to be able to have an environment that will scale up on demand. So they use tools like this to look at traffic, to look at people's search history, to be able to make sure that they understand which applications you want to use, and then based on that, they dynamically scale the environment to support those movies. Okay? This is something you can build into your environment. Again, using these tools, all of this replication and auto-scaling is built into Kubernetes. There's other tools you can use as well to be able to monitor traffic coming in. There's one that, imagine this, is called Traffic, and it's a container that you can load that will then help with auto-scaling. And it'll do it based on, the amount of traffic coming in. It'll do it from geographies, right? So it'll understand where traffic is coming in and maybe redirect them to a location that's closer. There's a lot of tools out there you can use. But this is just an example of using what's built into Kubernetes. So here's a situation where I've got a environment where, I've got this application up and running. Let me go ahead and give it a couple more instances of these containers. So we're going to launch them. And notice each time these change, right? And I'm adding different ones. They're ephemeral. It doesn't matter, right? I don't care about these containers anymore. As long as they're up and running, it's good to go. I don't care about the name. But this application, if I put something in, if I hit submit, it should be hitting the service, right? So it's not hitting the different components. So there's something wrong with the application. So as a developer, if I go in and I take a look, and I go into my environment, and I click on the application under GitHub, and I go into my puzzle application, and I go into the JavaScript there. So here I'm going to use Visual Studio. And I know that's impossible to see. I'll see if I can make that a little bit bigger. So here, I've got a number of components here within the logic of it. So I know that I've got an issue with the submit button on my application. So it looks like somebody commented this out. So here I'll go ahead and make that change. I'll save it. And then notice here, I can then submit this. Oh, hold on one second. So I can submit this back to source. So here I can say update, and then commit it, and then I can push that to GitHub. Okay? So now it's actually I made that change locally. I'm doing my GitHub push. So now on GitHub, you could actually go to this repository and you can see that change I just made. Now, in the background, I have that continuous integration server. So let's go back here to our web server here. And you can see this Jenkins build that I currently have. Now, I've set this to look for every 2 minutes. So while this thing is waiting, we'll see if it will go in and actually do that automated build. So this is the part, I guess, where I start to tap dance and wait for the build to happen. So every 2 minutes, this server is going to go out and check GitHub. And then based on that, so there we go. So expiring at 2.4 seconds, which is the longest 2.4 seconds in history. And now it's going through and doing a build. So it saw that commit. And you'll see it's going to go through the build process, the push process back to that repository, and then from the repository into the deployment. Now it's deployed in Kubernetes. So if we were watching that application, you would have saw each one of these scale down. Oh, come on, demo gods. All right, let's take a look at Kubernetes. Oh, it was going so well. Okay, it's still deploying. Yeah, it's taking a little bit of time because of the pulling stuff down from GitHub here. It takes a little bit of time. But we should be able to see this here in a second. There we go. And there we go. There's our 4 services back up and running. So now when I go through and I actually enter something into the puzzle, you can see where it's hitting all the different services. That's an example of continuous integration and deployment. So this is something that you can build in your local laptop to be able to experiment with this and play around with it. It's not something to be scared of, right? There is a learning curve. I won't lie to you. But it is something that once you start to get a little familiarity with it and start playing around with it, you'll see the power of some of these different tools, okay? Now, one thing that I will recommend is if you do it with VirtualBox, make sure you're using the 5.2 version of VirtualBox, not 6.0. There's a problem with the way that Minikube and VirtualBox gets a DHCP address. So if you use 5.2, it's fine. But every time you restart Minikube with the 6.0 of VirtualBox, it will actually give you a new IP address, and that causes a bunch of haywire with this application. But again, I will share this application in GitHub, or excuse me, in WebEx Teams, which will be to my GitHub website. You can pull this down, you can load this up, and play around with this on your own, okay? Boy, this touchscreen really wants to be touched. All right, there we go. All right, so what did we cover? We talked about a number of different things. We talked about what DevOps is. We talked about why DevOps matters. We talked about going faster with DevOps. So a lot of it hopefully provides you some context. Some of it was a bit of a history lesson. Apologize for that. But it's important to understand where we came from so that you can understand how to use it in the future, right? And then we talked about going faster with DevOps. All these tools are designed to be able to help you accelerate your application deployments. Many of the different things Cisco's building, our entire purpose is to be able to help you accelerate your deployments, to be able to make it easier. Take out the friction, take out the redundancy, remove the waste associated with getting these things loaded, and it allows you to be able to then focus on what the business is trying to accomplish. Allows you time to be able to experiment and try new things, and then ultimately, we showed you what DevOps looks like in action. So I gave you an example of an application that you can download, you can play around with, and give you an even better understanding of DevOps. I would highly recommend, if you get a chance, to read the Phoenix Project and the DevOps Handbook. Both of them are excellent books. In fact, there's another one that they're coming out with that goes even further into best practices. Lean is an interesting concept, and it's something I recommend you take a look at. When you start looking at your organization from that lean perspective, it starts to be able to help you to identify areas where maybe you can add some improvement. And last but not least, again, WebEx Teams. If you've got questions, if you experience some things here at Cisco Live and you'd like to ask me some questions about it, feel free to use WebEx Teams. I'd love to interact with you. If you've got any issues with downloading the code and things like that, ping me, and it'll be open a number of weeks afterwards. So hopefully you've enjoyed the session. We're going to end a little bit early. Please fill out your surveys. If you like the session, 5s are always good. And if you didn't like the session, just don't fill it out. But thank you so much. Hope you have a great rest of Cisco Live, and enjoy.